Assalamualaikum warahmatullahi wabarakatuh. I am Khairun Adhani binti Khairun Nizam. My matrix ID is MA18102. I am from Pahang. Today I'll be explaining the chapter 1 for experiment 3. Okay, the first one is the problem background. The first one is the friction losses is the sum of major losses and minor losses. Major losses come from energy losses due to the frictional energy loss caused by viscous effects of the fluid and roughness of the wall. And minor loss happen due to pipe fittings and changes in flow. As example, when the liquid flow change its direction and also change in area, it will cause minor losses. The last one, major losses will cause pressure drop. Next, this is the problem statement. Our problem statement is to find the suitable size of pump due to pressure drop caused by major losses. The objective of the experiment is to design complete measurement techniques for fluid flow. The second objective is to determine major and minor losses. And the last one is to investigate the velocity of the fluid for different types of pipes. That's all from me. Thank you.
Hello and Assalamualaikum. My name is Muhammad Hafiz Adnin bin Zaharuddin. My matric number is MA18081. I'm going to talk about the theory. Okay, for Reynolds number, Osborne Reynolds discovered that the flow regime depends mainly on the ratio of inertial forces to viscous forces in the fluid, and this ratio was called Reynolds number. The Reynolds number predicts flow patterns in various scenarios of fluid flow. Okay, so below we can see the formula for Reynolds number, where density times with average velocity times with diameter of the pipe and divide with fluid dynamic viscosity. The Reynolds number can be defined for several different situations where a fluid is in relative motion to a surface. This definition generally include the fluid properties of density and viscosity, plus a velocity and a characteristic length or characteristic dimension. For fluid of variable density such as compressible gases, special rules apply. Next is the flows in pipe. Okay, there is multiple types of flow exist in pipe, which is the laminar flow, where the Reynolds number less than 2300. The transient number, the Reynolds number is in between 2300 and 4000. And last but not least, the turbulent, the Reynolds number more than 4000. The laminar flow was visualized as smooth, streamlined, and highly ordered. The flow is in laminar phases when Reynolds number is below 2300, and it was fully developed if the pipe is necessarily long enough where entrance effect could be ignored. Each fluid particle in fully developed laminar flow move at a constant axial velocity along the streamline, and the velocity profile remains the same in the flow. So for turbulent flow, the turbulent flow is a complex mechanism governed by variability, which is still not completely known. Considering the enormous amount of research in this field, turbulent flow is characterized by the uneven and sudden changes in swirling fluid areas, known as eddies, that has Reynolds number more than 4000. These fluctuations provide an additional mechanism for momentum and energy transfer. In turbulent flow, the swirl eddies carry mass, momentum, and energy much faster than molecular diffusion into other flow areas, increasing mass, momentum, and heat transfer considerably. This result So next is the head loss. The head loss HL represents the additional height that the fluid needs to be raised by a pump in order to overcome the frictional losses in the pipe. The head loss was caused by viscosity and it is directly related to the wall shear stress. Head loss could be calculated using the formula given, where
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Razim Roshdam bin Muhammad Rashid, MA 18114. I will present the methodology. In this experiment, we have to prepare the pipe friction apparatus to ensure that pipe is working in good condition. The hydraulic bench was checked to make sure the load measures the resulting discharge and also take time required by the water flow from the start of the current until the load level is lifted due to the water load. Pressure sensor was inserted into the inlet and outlet pipes that can convert the pressure into an analog electrical signal. During the data acquisition process, the flow rate indicator was used to measure the volumetric flow rate. For this procedure in this experiment is for straight pipe. First one is pipe friction apparatus was inspected to ensure that it was in proper working order so that any error in the result could be minimized. The valve was turned left to open the valve. The pump is turned on. The control race was used to adjust the volume. Then the unused valve was closed. Pressure sensor was used to measure the pressure variation between the inlet and outlet pipes. The volume flow rate was calculated by flow rate indicator. The results were recorded and tabulated. For elbow, 45-degree pipe and pipe bands. For the experiment, steps 1 to 5 from the straight pipe friction experiment is repeated. A pressure sensor was used to measure the pressure variation between the inlet and outlet of pipe elbow, 45-degree valve and pipe bands. The results were recorded and tabulated.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mekab Azmin. Today I would like to present about discussion. First question is about explain how the strain gauge sense the pressure. Strain gauge are sensing device used in a variety of physical tests and measurement application. They change resistance at the output terminal when stretched or compressed. Because of the characteristic, the gauge are typically bonded to the surface of a solid material and measure its minute dimensional change when put in compression or tension. In this experiment, the strain gauge convert the pressure detected by water inside the tube into resistance. The value of resistance will produce potential difference, which is voltage, which is DAQ able to show this information in our computer and result obtained. Second question is about what will happen to the head loss if the diameter of the pipe is increased. Based on the formula, the head loss is inversely proportional to the diameter. If the inside diameter of the pipe is reduced, the flow area decrease, the velocity of the liquid increase, and the head loss due to the friction increase. Hence, it can be concluded that when the diameter of the pipe is increased, the head loss will increase. The second question is about what will happen to the head loss if the length of the pipe is decreased. Based on the formula, the head loss is directionally proportional to the length. Head loss due to the friction occur all along a pipe. It will be constant for each foot of pipe at a given flow rate. The published table have head loss value which must be multiplied by the total length of pipe. Hence, it can be concluded that when the length of the pipe is decreased, the head loss will also decrease. The third question is about what are the two types of energy loss typically associated with the pipe flow. What determines which one will predominate as the most significant loss of head incurred by a fluid flowing along a pipe? The third type of energy loss typically associated with the pipe flow are major head loss and minor head loss. Major head loss happen along the process of the fluid flow along the pipe due to the friction. Minor head loss happen due to the system of the pipe, which is the type of elbow, valve, and TUs. The fourth question is about how can you find the value of final loss coefficient for the experiment. The minor loss in a component depend mainly on the geometrical structure of the component and the effect of a construction, as on the fluid flow due to the change in the velocity and the cross of fluid acceleration. The minor loss in this experiment can be determined from the formula as shown. Minus loss coefficient is K equal to GH loss divided by V squared. The fifth question is about compare your critical Reynolds number with the theoretical value at which the transition from laminar to turbulent flow occur. What the most significant reason for the difference between the two? The theoretical, the Reynolds number of the laminar flow are 2300 to 4000 to 3000 to 4000 for transition flow and more than 4000 for turbulent flow. The transition of the water flow from laminar to turbulent usually happen due to the friction and the increase in velocity of water. Experimentally, how Reynolds number are more than 4000, thus this show that the turbulent water occur along the pipe. As the conclusion of this experiment, in conclusion, there are some difference between theoretical and experimentally result. The difference may due to the lack of efficiency of sensor in receiving the input of the movement of fluid. Through the experiment, we had learned a lot about the fluid movement in the pipe with different systems between elbow pipe, bend pipe, and 45 degree of angle pipe. From the data we received from the sensor, it showed that elbow pipe caused the most heat loss. The result of the experimental calculation support the theoretical calculation in determining which had the most heat loss. The data influenced the result of the lab, that's the flow rate of the water through the pipe. The data or electrical signals sensed by the strain gauge and the flow sensor are analyzed and determined by using the visual instrument software, DAISY-Lab. We key in the parameter formula to generate all the database. At the end of the experiment, we managed to determine which size of the pipe and the type of the pipe that's suitable for certain condition. The type of flow also will affect the loss inside the pipe. Then it is important for us to use this method of experiment at the future inside any related industry to test the most suitable condition of pipe that we need to use. I think that's all for me. Thank you very much.